The new pictures captured by the James Webb Space Telescope have taken researchers by surprise, revealing disclosures about the universe that were not expected. Rather than merely expanding our comprehension of the universe, these pictures have unveiled a baffling reality, showing that our current knowledge is insufficient to fully grasp the immense possibilities of the universe's early existence. The established hypotheses regarding the origins of the universe now appear to be pushing their limits, prompting a need to explore adaptive speculation about its formation. This presents the fundamental question of how the universe came to be and why. These discoveries are challenging even the most seasoned experts in space science, driving a deeper examination of the true nature of the Big Bang and its ever-evolving complexities. It may now be time to rethink the theory of the Big Bang itself, as public perceptions of it have often been misrepresented. The Big Bang was not simply an explosion within pre-existing space. Rather, it marked the birth of space itself, unfolding approximately 13.8 billion years ago along with matter and time. A critical concept in modern science and cosmology is the idea of a singularity, a point where gravity becomes so extreme that the curvature of spacetime becomes infinite. Billions of years after the universe's birth, we now see that our cosmic home is part of a vast interconnected system. For scientists, this discovery represents a significant aspect of the universe's existence, highlighting its continuous expansion. The universe does not merely drift into existence. Space itself is expanding, as conventional theories suggest. It is believed that the first stars began to shine around 200 to 300 million years after the Big Bang, marking the end of the so-called dark age of the universe. This was when the first bright stellar objects formed and evolved into galaxies. However, the speed at which these galaxies developed remains shrouded in mystery. A major breakthrough came on July 22, when the first images from the James Webb Space Telescope revealed several galaxies, some of which were already in existence around 300 million years after the universe's creation. Though younger than the galaxies we see today, these early galaxies were smaller and less massive, aligning with scientific models of the time. During the early universe, the density of matter was too low to form galaxies as large as those we see now. This discovery began with the detection of 6 remarkably redshifted bright spots by the James Webb Telescope, igniting one of the most significant cosmic puzzles of recent years. These newly discovered galaxies, though similar in age to previously identified ones, appeared nearly as massive as our Milky Way. This revelation has captivated researchers in the field of Big Bang cosmology. When scientists analyzed a series of images taken by the telescope's near-infrared camera, they confirmed the presence of these distant objects using redshift data. This indicated that the light from these galaxies had traveled for over 1 billion years before reaching Earth. This means these galaxies were already in existence between 570 and 700 million years after the confirmed Big Bang. This extraordinary finding challenges conventional cosmological expectations, which had predicted the formation of much smaller, less developed galaxies at this stage of the universe's history. Instead, the James Webb Telescope unveiled galaxies nearly as massive as the Milky Way, defying these predictions. The gravitationally bound stars in these galaxies had already accumulated mass exceeding 10 billion times that of the Sun. One of these galaxies even showed signs of having a mass greater than 10 billion solar masses. However, whether this theory is entirely accurate remains open to debate. If these findings are correct, the mass in the early universe would be far greater than expected, creating a far more complex puzzle. The discovery of these galaxies poses a significant challenge to nearly all conventional cosmological theories. Even if one of these galaxies is proven to be accurate, it would force us to rethink our assumptions regarding the existence of these early cosmic structures. The matter density in the early universe would need to be far greater than initially expected. Another possible explanation is that these galaxies formed in ways that are entirely unknown to us. These discoveries are raising questions that demand a reassessment of the Big Bang theory. Many space scientists are frustrated by these revelations, and their concerns are often voiced in scientific publications. Those who challenge the prevailing theories are frequently labeled as fringe or extreme. Nevertheless, it is clear that even those who continue to defend the Big Bang theory face unresolved questions. Among these questions is the fundamental issue of how, 13.8 billion years ago, something could arise from nothing. Could something truly emerge from nothing? Or was there a catalyst for this event? Or did it happen randomly? Stephen Hawking famously pointed out that the concept of time, as we understand it, began with the Big Bang. Therefore, this process could not have been initiated by something else or triggered by an external cause. Similar questions arise concerning the uniformity of radiation and matter throughout the universe. Regardless of where we look or at what distance we observe, we see a similar distribution of systems, nebulae, and radiation across the cosmos. Modern scientists explain this phenomenon with the theory of cosmic inflation. Other researchers have expanded this theory, suggesting that the universe has expanded in a turbulent manner. According to this model, expansion occurred only in localized areas, like bubbles, while other regions continue to expand indefinitely. This model raises the intriguing possibility that other universes may exist within these expanding bubbles, each governed by its own set of physical laws. Such a perspective suggests that our universe may not represent the entirety of existence but rather be part of a larger and more complex structure. Within this framework, the idea of an eternal cycle of collapse and rebirth for the universe is proposed. However, this is just one of many theories in cosmology. For example, an article published in NASA's Spacetime magazine in 1955 proposed that the universe may never have had a Big Bang and could have always existed, possibly for an infinite period. In this interpretation, the expansion of the universe would be absent, with the continuous evolution of matter giving the impression of gradual development over time. One particularly captivating hypothesis arises from quantum physics and string theory. Some experiments have hinted that our entire universe could be a projection or simulation from a higher dimensional reality. While this might sound like the premise of a science fiction story, it connects with the Kardashev scale, which measures a civilization's ability to harness the energy of an entire universe. A Type 3 civilization, capable of utilizing the energy of a universe, could potentially create a perfect simulation of a universe. However, proving the validity of such a scenario is a daunting challenge. Exploring the depths of cosmology and the origins of the universe brings us into a realm of great mystery and relentless scientific inquiry. The new pictures from the James Webb Space Telescope have reignited debates about the very fabric of existence, putting established theories to the test and urging scientists to reevaluate core principles of our understanding of the universe. Our universe is a projection from a higher dimensional reality. It raises profound questions about the nature of existence itself. Are we part of a grand, interconnected cosmic structure? Or are we isolated in a universe with its own set of rules? Could there be other forms of life or intelligence in universes with different physical constants? And if so, what does that mean for our understanding of life and consciousness? These revelations challenge our place in the cosmos. If the universe is not unique, but rather one of many, it forces us to reconsider our significance. It also invites philosophical debates about determinism, free will, and the role of human beings in the grand scheme of things. Could our existence be part of a larger cosmic experiment? Or is it the result of random chance? Furthermore, the discovery of galaxies that appear to have formed much earlier than expected prompts us to question the very nature of time. If these galaxies existed so soon after the Big Bang, does that mean the universe itself was much more complex and evolved much faster than we previously thought? Could the laws of physics have operated differently in the early universe? And what does that mean for our understanding of the passage of time? The findings also challenge our understanding of space-time. The concept that the Big Bang was not just a moment of explosion, but the birth of space itself, forces us to rethink the origins of the universe. If space-time itself began with the Big Bang, how can we comprehend the nature of reality before this event? Is it even possible to conceptualize a time before time itself? As scientists continue to explore the implications of these discoveries, they will likely encounter more questions than answers. The universe is far more mysterious and complex than we ever imagined, and the new data from the James Webb Space Telescope is only the beginning of a new era in cosmology. Each discovery leads to more questions, pushing the boundaries of what we know and challenging our most fundamental assumptions about the universe. In the coming years, the quest to understand the true nature of the universe will continue to evolve. The answers may lie in the depths of dark matter and dark energy, in the uncharted realms of quantum mechanics, or in the exploration of alternate cosmological models. Whatever the outcome, these discoveries promise to reshape our understanding of the cosmos and our place within it. The future of cosmology is both exciting and uncertain, but it is clear that the journey to unravel the mysteries of the universe is far from over.